All right. We've got another calculator tutorial today, and this is our first of chapter 9. It's a one proportion z-test. I'm going to show you two just to mess around with the features a little bit. There's really only one thing about it that changes it all. But to get started, it is stat and test, right? Our test and our test features, our confidence intervals, they're all conveniently kind of put together in the same spot as you would like. We're after option number 5, a one proportion z-test. So we'll scroll down. I've got data from one in your notes. This is from the first day. It's the American Idol problem. Okay. First thing I got to put in is my hypothesized parameter value. Obviously, in this case, a proportion, which was 1/12. You can see as soon as I put it in, the calculator switches it to a decimal, which is fine. That number had told us that if the randomly selected fans viewing the tapes, and they're in random order, you know, we would expect, if going last didn't matter, that about 8.3% would pick the last one as their favorite. Okay. X and N, those will always be given. We had 59 that picked the last tape out of a sample size of 600. This part could probably be the trickiest. You have to choose not equal to, less than, or greater than. You should be going to the calculator after you've written HO and HA. Okay. The first option that's highlighted right now is a not equal to. That's not the one I want. The one where the cursor is blinking on is a less than. That's not it either. I want a greater than because we had suspected that if going last was advantageous, which we think it might be, that the actual proportion would be higher than 1/12. But again, at this point, you should have already have written HA, and the one you pick should look exactly like it, right? And HA should say that P is greater than 1/12. We go and calculate. We have a gold mine of stuff. The z-score, we call that our test statistic. That's huge. Our do step of our 4 step, we have to have that number, 1.33. There's our p-value. That's huge. Okay, the result of this test was a fail to reject because our p-value of 0.0919 was bigger than alpha. P-hat, that's just 59 divided by 600. Probably already knew that. And N is 600. So those last two things, they're good to know about the problem, but we don't have to include those in our do step. But the z-score and the p-value, we do. All right, one more, just to mess around with the features a little bit. It's obviously still stat test 5. This is from day 2. It's the Benford's law problem about the leading digits of a 1 in various financial documents. Okay. 0.301, that's the same, right? That's your hypothesized proportion. We had 68 expenses that had a leading 1 out of a random sample of 300. Okay. This is the part I wanted to come back to, that in HA, it said that P was not equal to 0.301 because we would suspect fraud if that number is too high or if it's too low, right? Either way would be concerning. So I would go ahead and select the not equal to, and I go ahead and calculate. Okay. And again, for that do step, we want really the first two, that test statistic of -2.81, and we definitely want that p-value of 0.005.